Today let us look at factorization of quadratic equations. Let us take a quadratic equation x square minus 3x minus 10 is equal to 0. Now if we were to look at the polynomial on the left hand side, recall that we have done factorization of such quadratic polynomials. So factorization of quadratic equations is similar to factorizing a quadratic polynomial and equating it to 0. Let us write the coefficient of x square as 1. Now we could split the middle term of the polynomial on the left hand side. So let us look at the coefficient of x square and the constant term. Now the product of these two is minus 10. Now we have to find two factors of minus 10 that would add up to minus 3. Now there are only two prime factors of 10, 5 and 2. Now since we need a minus 3, the bigger number would need a minus sign. So we could write minus 5 plus 2. So let us split the middle term and take the first two terms together and the third and fourth terms together. Let us see if we can take anything common. Now we have to make sure that the terms in the bracket are the same. So we have obtained x minus 5 as a bracket from both the pairs. Simplifying, we get x plus 2 times x minus 5 is equal to 0. Now note that these two brackets, x plus 2 and x minus 5, are factors of the quadratic polynomial on the left hand side of this equation. Now since the product of these two factors is equal to 0, that means that at least one of them has to be 0. So we could write that either x plus 2 is equal to 0 or x minus 5 is equal to 0. Solving these two, we get x equals minus 2 or x equals 5. Now these are known as the roots of this quadratic equation. So note that we found out the factors of the polynomial and roots of the equation. Let us look at a few problems. Find the roots of the quadratic equation 6x square minus x minus 2 is equal to 0 by factorization. So let us write the equation once again and look at the coefficient of x square and the constant term. Always remember that the right hand side of this equation has to be 0 before we factorize. So we get 6 times minus 2, which is equal to minus 12. Now we need to find two factors of minus 12 that would add up to minus 1, which is the middle term. So there are two pairs possible, 6 and 2 or 4 and 3. Now which of these pairs would add up to minus 1? Yes, minus 4 plus 3. So let us split the middle term, take the first two terms together and the last two terms together and find out if we can take anything common. Make sure that the terms in the bracket are the same. And we have found out the factors of the polynomial. Now one of these factors has to be 0. Now solving these two linear equations, we get x is equal to minus 1 by 2 or x is equal to 2 by 3. So minus 1 by 2 and 2 by 3 are roots of the given quadratic equation. Let us look at another problem. Find the roots of the quadratic equation square root of 2 times x square plus 7x plus 5 root 2 equals 0 by factorization. So we have a 0 on the right hand side, which means that the polynomial is on the left hand side. So let us look at the coefficient of x square and the constant term. We are dealing with surds here. So let us multiply square root of 2 with square root of 2. And we get 5 times 2 equals 10. Now, we need to find two factors of 10 that would add up to 7. There is only one pair possible, 5 and 2. And 5 plus 2 would give us 7. So let us split the middle term. Now taking the first two terms, we see that x is common and we get a square root of 2 times x plus 5 in the bracket. Now recall that the bracket obtained from the third and fourth terms has to be the same. So what could we take common from the third and fourth terms? Square root of 2, correct. Simplifying, we have found the two factors of this quadratic polynomial. Now let us equate each of these factors to 0 and solve these two linear equations. We get x is equal to minus square root of 2 and x is equal to minus 5 divided by square root of 2. So minus square root of 2 and minus 5 by square root of 2 are roots of the given quadratic equation. You could simplify the second factor and write it as minus 5 square root of 2 divided by 2 as well. Let us look at another problem. The altitude of a right triangle is 7 centimeters less than its base. If the hypotenuse is 13 centimeters, find the other two sides. So we are given a right triangle and we are given its altitude and base. Now altitude is given as base minus 7. We are also given the hypotenuse as 13 centimeters. Can you recall any property concerning all three sides of a right angle triangle? Yes, it is the Pythagoras theorem, which says that base square plus altitude square is equal to hypotenuse square. Now let us write the base as x centimeters. So the altitude becomes x minus 7 centimeters. Let us put these values in the Pythagoras theorem and open x minus 7 whole square. Can you recall the algebraic identity a minus b whole square? Yes, it is a square minus 2ab plus b square. Let us apply that to x minus 7 whole square and put it in the Pythagoras theorem. Now let us collect the like terms together and simplify. We could take 2 common from this polynomial. Now since 2 is not equal to 0, the polynomial has to be equal to 0. Let us write the coefficient of x square as 1 and try to split the middle term. We see that the product of coefficient of x square and the constant term is minus 60. Now the factors of 60 possible are many, but we need a minus 7 as their sum. So minus 12 plus 5 seems to satisfy the middle term. Let us split this middle term and simplify. So we get x is either minus 5 or x is equal to 12. But we are looking at lengths of sides. So the length of a side cannot be negative. Hence x has to be equal to 12. Substituting this value, we get base as 12 centimeters and altitude as 5 centimeters. You could also check this result by applying the Pythagoras theorem once again. So 5 square plus 12 square gives us 13 square, which means that our answer is correct.